She has 7 spots. She is red. She is drawn on children's notebooks, on mugs, on postcards. Every child knows her name, a symbol of summer, a symbol of the garden, a symbol of something kind and small. But today we are talking about a different one. The one we are talking about is yellow. She has 22 spots. She is half the size of the one you know. In her entire life, she has never eaten a single aphid, not once. She eats what you cannot get rid of for years. What destroys cucumbers, pumpkins, and gooseberries every August. What takes your money, time, and several treatments per season. And she is living on your garden beds right now. You have probably crushed her, because in most gardening reference books, she is still listed as a pest. But more on that later. Hello, today we are talking about the 22-spot ladybird and the entire family she belongs to. 6,000 species, 100 million years, one Asian invader that is currently marching across Russia, and one small yellow beetle that does in your garden the work you pay money for every season. Stay until the end. Let's start with what everyone gets wrong. The family Coccinellidae, what scientists call ladybirds, is one of the most recognizable on the planet. 3-year-old children know them. They are drawn in ABC books. They are used as logos for children's products all over the world, and yet most people have only one image in their heads: red, 7 spots, kind. The reality is far more interesting, and in some places much scarier. Over the past 20 years, an outsider from Asia has arrived in this family and has begun displacing everyone else. Yellow ladybirds, which for centuries quietly protected gardens from fungus, suddenly found themselves under threat. The red 7-spot ladybirds, which we consider a symbol of summer, have become rare in Western Europe where there used to be millions. And it has also turned out that one of the most common ladybirds in Russian gardens, that very same yellow one with 22 spots, works as a biological fungicide, without chemicals, without a sprayer. She just lives and eats what gardeners have been unable to get rid of for decades. We will talk about all of this. Let's start from the very beginning, with a question that is rarely asked. Where did ladybirds come from in the first place? How did a brightly colored beetle become one of the most successful predators in the world of insects? And why exactly was this strategy, being conspicuous rather than hiding, so winning for millions of years to come? Ladybirds appeared about 100 million years ago. For comparison, by that time, dinosaurs had already existed for 150 million years and felt like the masters of the planet. Humans would appear only 99.5 million years after the first ladybirds. The first coccinellids were small beetles that lived in forest litter and, apparently, fed on fungi and decay. Nothing special, nothing that foreshadowed their future success. But around the same time, something important was happening on the planet. Flowering plants were spreading rapidly, and with them, aphids. Aphids are small, soft-bodied insects that pierce a plant stem and suck out the sap. Aphids reproduce at such a speed that, without predators, one colony can cover a bush in a few days. One bush, in a week, several. A whole field, in a season. And this is where ladybirds made their move. Some species switched from fungi to aphids. At first, probably by accident. They tried it and found it nutritious and accessible. Then, more and more actively. Aphids were literally everywhere. They didn't run away, they were soft and juicy. The transition to feeding on aphids triggered an evolutionary process that changed ladybirds forever. They no longer needed to hide. On the contrary, it became advantageous for them to be conspicuous. Here's why. Ladybirds secrete a caustic liquid from the joints of their legs, hemolymph with alkaloids. It tastes disgusting. A bird that grabs a ladybird gets a burning sensation in its mouth and remembers it forever. The red color with black spots is a warning that works without words on all continents and for all predators with color vision. Being red and conspicuous means being protected. Hiding is pointless if you will be found anyway. It is better to shout to everyone around, "I am distasteful, don't waste your time." This strategy turned out to be so successful that several different lines of beetles arrived at it independently. Not only coccinellids, other beetles, bugs, and some butterflies also became bright and bitter. Nature invented the same solution several times because it worked. Over 100 million years, the family grew to 6,000 species on all continents except Antarctica. Different climates, different ecosystems, different diets, but one and the same basic principle. Be conspicuous, be bitter, live long. When people say ladybird, most see one image. In reality, 6,000 species is almost as many as all species of mammals on the planet combined, and they are amazingly diverse. Let's start with what immediately catches the eye: the spots. The spots on ladybirds are not decoration and not random. The number of spots, their color, and arrangement are a species characteristic, like a passport. The 2-spot ladybird is one species. The 7-spot is another. The 24 spot is a third. The 22 spot is a fourth. But here is what is interesting. Even within one species, the pattern can vary greatly. The Asian ladybird, which we will talk about separately, is the champion of variability. It can have from 0 to 22 spots. Some individuals are almost black, others are reddish with barely noticeable spots. Formally, it is one and the same species, but outwardly, as if different creatures. Now about color. We are used to ladybirds being red, but red is only one of several working options. Yellow with black is no less effective a warning. Orange, white with black, even blue. Yes, there are blue ladybirds of the genus Halmus. They live in Australia and New Zealand. There are ladybirds whose color scheme is reversed, not a red background with black spots, but a black background with red spots. This is not a different signal. It is the same signal, just inverted. Predators understand both variants equally well. Now about size. The smallest ladybirds are less than a millimeter long. These are tiny creatures that live on plants and are almost impossible to see without a magnifying glass. The largest reach 10 to 12 millimeters. Of course, far from a Hercules beetle, but for a family where the average size is 3 to 5 millimeters, this is quite significant. Our heroine today, the 22-spot ladybird, Silabora vigentiduopunctata, is at the lower end of the size range, 3 to 4 millimeters. For comparison, the 7-spot ladybird that everyone knows is 7 to 8 millimeters, so ours is almost half the size. But size is not the most interesting thing. The most interesting thing is what they eat. Most people think that all ladybirds eat aphids. This is not true. The 6,000 species are divided into several fundamentally different feeding strategies. Predators are the largest group. Aphids, mites, whiteflies, scale insects, small caterpillars. It is the predators that make up the majority, and it is they who made the family famous. Fungus eaters, mycetophages, a small but important group. They eat not animals but fungi, powdery mildew, and related pathogens. The 22-spot ladybird belongs exactly here. Herbivores, those that gardeners dislike. Several species switched from aphids to plants and became pests. For example, the 28-spot potato ladybird, Epilacna vigentiactopunctata, devours the leaves of potatoes and eggplants. Outwardly, it looks very similar to the good ladybirds, which creates confusion. Omnivores eat both, depending on availability. I remember when I first learned that within one family there are both predators, plant-eating pests, and fungus eaters. It completely turned my idea of what a ladybird is. It is not one type of creature. It is a whole spectrum of strategies packaged in a similar appearance. Before moving on, it is worth stopping at the name. Why is a ladybird called a cow, korovka? The beetle doesn't look like a cow at all. It doesn't moo. It doesn't give milk. It doesn't graze in the meadow. There seems to be no logical connection, but there is one, simply hidden in language. There are several versions. The first is through Old Slavic. In Old Russian, the words for cow and blood had a common root. When in danger, the ladybird secretes an orange-red liquid from the joints of its legs. Peasants who saw it could call the beetle blood or bloody one, and over time this transformed into little cow. The second version is symbolic. In peasant culture, the cow was a nurturer, a creature under special protection. A beetle that saves the harvest from aphids could well have received the same name, as a helper and protector. The third version is through the German word Käfer, beetle. In some German dialects, ladybirds were called Mukäfer, cow beetle. The Russian korovka could be a calque from this word. None of the versions have been definitively proven, and that in itself is interesting. The beetle is so ancient and has entered culture so deeply that its name has lost its direct connection to its origin. In other languages, it is even more interesting. The English ladybird or ladybug, bird of Our Lady or beetle of Our Lady. In the Middle Ages, the Virgin Mary was depicted in a red cloak. A small red beetle that flew in and ate the aphids, destroying the harvest, was perceived as a messenger from heaven, literally help from above. The name stuck and has survived to this day. German Marienkäfer, Mary's beetle. The same logic. Mary, red color, protection. French bête à bon Dieu, creature of the good God. Italian coccinella, from Latin coccineus, bright red. Interestingly, in all cultures that knew the ladybird, it received names with a religious or sacred connotation. Not red beetle, not spotted beetle, but the beetle of Our Lady, Mary's beetle, God's creature. A small being that comes and saves the harvest received a name in accordance with what it meant to the peasants. In Russia, ladybirds were called differently depending on the region. Little sun, God's little cow, Maryashka, little bug Maryashka. Everywhere, something warm, homely, under the protection of higher powers. There was also a superstition passed down from generation to generation. If a ladybird flies off your palm quickly, good weather is coming. If it lingers and crawls, rain. Peasants observed insects as a barometer, and strangely enough, they were not always wrong. Insect behavior really does change with changes in atmospheric pressure. And now, to what this is all for, to our yellow heroine. The 22-spot ladybird, Silabora vigentiduo-punctata, looks as if it was drawn by a child given a yellow marker and a very fine black one, yellow background. 22 black spots on the elytra, 11 on each, arranged strictly symmetrically as if by a ruler, plus another 5 spots on the pronotum, the small shield between the head and the elytra. In total, there are more spots on the body than in the name. Size, 3 to 4 millimeters. This is about the size of a large grain of rice. The 7-spot ladybird everyone knows is twice as large. Ours is one of the smallest ladybirds in the Russian fauna. Yellow with black is just as effective a warning to predators as red with black. Nature uses this combination everywhere. Wasps, bumblebees, some spiders, several species of frogs. Any creature with color vision quickly learns. Yellow and black means bitter, stinging, or poisonous. Better not to touch. But what distinguishes the 22 spot from most of its relatives is not its appearance, but its diet. Almost all ladybirds are predators. They eat aphids, mites, scale insects, small caterpillars. This is why gardeners value them. This is why peasants gave them names associated with protection and heavenly patronage. The 22-spot ladybird does not eat aphids at all. Never in its life. It eats powdery mildew, not insects, not eggs, not larvae, only the fungus, microscopic mycelial threads that cover the leaves with a white coating. That very same white powdery coating that drives gardeners to despair every August. This is called mycetophagy, feeding on fungi. And within the ladybird family, this is a separate evolutionary direction, small in number of species, but with a very interesting history. How does the ladybird find the right leaf in a huge garden? It doesn't inspect every one. It has a chemical navigation system that works through its antennae. When powdery mildew is actively developing, it releases volatile organic compounds into the air, a byproduct of its metabolism. The fungus lives and breathes like any living organism. For the plant, these compounds are a distress signal. For the 22-spot ladybird, the smell of food. The beetle detects this smell with its antennae from a distance of several meters. It flies precisely to the affected leaf, lands, begins to eat. Have you ever been surprised how flies instantly find food in the kitchen even though they weren't there a moment ago? The same mechanism. Only in the ladybird it is tuned to one specific smell that it has been searching for over millions of years of evolution. And one more important point. The female, when choosing a place for egg laying, also uses this smell. She does not lay eggs just anywhere. She looks for a leaf with the most active infection. The stronger the powdery mildew, the more attractive the leaf for future egg laying. Because the larva that hatches must immediately find itself next to food. This is not random. This is precise calculation, honed by evolution over millions of years. To understand why the 22-spot ladybird is important, you need to understand exactly what it is fighting. Powdery mildew is not one fungus. It is an entire order of fungi with the scientific name Erysophales, about 900 species. Each specializes in its own host plants, and this specialization is very strict. The fungus that attacks cucumbers will not move to roses. It does not have the right tools for that host. The fungus from gooseberries will not touch phlox. The fungus from cereals is not interested in pumpkin. Each species of powdery mildew is a narrow specialist tuned to a specific group of plants. This is important to know because it explains one thing. When you see white coating on cucumbers and roses at the same time, it is not the same fungus that is spread throughout the garden. These are two different fungi that simply live side by side. What does powdery mildew look like from the inside? The white coating is mycelium, fungal threads that spread right over the surface of the leaf, not inside it, on the outside. Most pathogenic fungi penetrate plant tissues. Powdery mildew lives on the surface of epidermal cells, but it feeds from the inside. The fungus sends special feeding organs, haustoria, into the cells. Through them, it sucks out the cell contents without destroying the shell. The cell looks alive from the outside. From the inside, it gradually empties. A leaf covered with powdery mildew looks as if it has been dusted with flour on the outside. Inside, the cells slowly die. Powdery mildew spores are spread by the wind. And here is a detail that is a bit unsettling. These spores are right now in the air of your garden, on any summer day. The only question is whether they will find suitable conditions for germination. The conditions are simple: warmth and slightly elevated air humidity. Not rain, not puddles, specifically air humidity. That is why powdery mildew is especially active at the end of summer, when nights become cooler and more humid, while days are still warm. The perfect incubator. The fungi of the order Erysiphales lilies appeared together with flowering plants. This means that powdery mildew has existed for at least 100 million years. It has survived ice ages, climate changes, and the extinction of dinosaurs. It has adapted to tens of thousands of plant species. It is resistant to drought. Spores survive for months. It quickly develops resistance to fungicides with regular treatment. In a bad season, powdery mildew can destroy a third of the cucumber harvest, and that is a conservative estimate. On the scale of Russian vegetable growing, this is billions of rubles annually. And against this ancient, intelligent, ubiquitous enemy, nature has a small yellow beetle with 22 spots, which we, not knowing this, crush along with the pests. How exactly it works, that is in the next chapter. The adult beetle scrapes the mycelium from the leaf surface with specialized mouth parts. It does not pierce the leaf, does not suck out cell sap, it precisely scrapes the surface layer. After the beetle's work, characteristic traces remain on the leaf, eaten areas of white coating mixed with untouched ones. The leaf looks a little ragged. This is exactly what misled gardeners for decades. They saw the beetle on a sick plant, saw traces on the coating, and concluded the beetle is damaging the plant. The logic is understandable, only it is exactly the opposite of reality. Without the ladybird, this leaf would be covered with a solid white felt and would slowly suffocate under it. With the ladybird, the fungus is removed, the cells gain access to light, and the plant continues to live. One adult beetle clears an area of several square centimeters of leaf surface per day. Not much, but there are many beetles, and they work continuously. The life cycle of the 22-spot ladybird is 1 year. In spring, when the temperature stably rises above 10 degrees, the overwintered beetles emerge from their shelters. They overwinter in leaf litter, under bark, in cracks of fences and wooden structures, where it is dry and there is no direct frost. Unlike some other ladybird species that overwinter in large groups, the 22-spot prefers to overwinter alone or in small clusters. The first weeks after emergence are a recovery period. The beetle feeds and builds up resources, then mating. The female lays eggs directly on leaves affected by powdery mildew, not just anywhere nearby, exactly where food is already present. The eggs are small, yellow, oval, less than a millimeter. They are easy to miss. 1.5 to 2 weeks later, larvae appear. And here is another story about a mistaken diagnosis. The larvae of the 22-spot ladybird look nothing like the adult beetle. Grayish yellow, elongated, with dark, warty outgrowths on the sides. They look strange. Most people who see them for the first time mistake them for some unknown pests and crush them. This is a mistake. The larva eats the same powdery mildew as the adult beetle, and it eats actively, possibly even more actively. The larva goes through 4 stages of development, 4 instars, as entomologists call them. Each time it molts and becomes larger. The entire larval period is about 3 to 4 weeks. Then, the pupa, right on the leaf, without a cocoon, yellow, immobile, attached to the surface. In 1 to 2 weeks, a young beetle emerges from the pupa. At first, it is pale. The spots have not appeared. The elytra have not hardened. Within a few hours, the color becomes saturated, the chitin hardens, and before you is a ready 22-spot ladybird. Over the summer, 1 or 2 generations manage to complete their cycle, depending on the climate and seasonal temperatures. Have you ever noticed a small yellow spotted beetle on your cucumber leaves? Or strange gray larvae next to the white coating? Write in the comments which regions you are from. I am genuinely interested in this geography. In Soviet agronomic literature, the 22-spot ladybird was listed in the sections on pests, not because someone conducted research and proved harm, but because the logic was, a beetle on a sick plant, therefore the beetle is to blame. Observation without a control experiment. You see the effect, you call it the cause. The recommendations were appropriate: collect by hand, treat with insecticides, destroy. Gardeners followed the advice. They killed the beetle. Powdery mildew did not disappear. On the contrary, it progressed. But this fact did not alarm anyone because powdery mildew was treated separately anyway, with copper sulfate, colloidal sulfur, fungicides. The biological connection between the beetle and the fungus did not exist in mass consciousness. Only in the 1980s did Soviet entomologists begin to publish works that directly stated, Syllabora vigentiduopunctata is a mycetophage, that is, a fungus eater. Its presence on affected plants is a sign of natural biocontrol, not an attack. But inertia is great. In popular gardening publications, the beetle remained on the list of unwanted guests for a long time. Some websites still keep it there. The price of this mistake is decades of applying fungicides where a living biological agent could have sufficed. Gardeners' money, chemicals in the soil, and destroyed populations of the beetle that was simply doing its job. The story is not unique in the world of insects. Shrews were long considered pests, until it was discovered that they destroy huge numbers of harmful insects. Spiders in the garden were perceived as a threat, until it was understood that they keep aphids and small flies under control. The pattern is the same. An unfamiliar creature on a damaged plant equals the culprit. The right question sounds different. What would happen to this plant without this creature? The 22-spot ladybird is not the only fungus eater in the family. It is part of an entire evolutionary direction. Within Coccinellidae, there is a separate tribe, Halazini, several dozen species across the planet, and all of them are exclusively fungus eaters. All specialize in powdery mildew or related fungal pathogens. Different continents, different climates, different host plant species, but one and the same feeding strategy. This means one important thing. The transition to feeding on fungi was not a random mutation of one species, but a successful strategy that gave rise to an entire direction. Either it happened once and the direction turned out to be promising enough to produce dozens of species, or the transition to fungi occurred independently in different lines, and each time it turned out to be advantageous. Why is this advantageous? Among predatory ladybirds, there is fierce competition for aphids. 7-spot, 2-spot, 10-spot, 14-spot. They all hunt in roughly the same niche for the same food. When there is little aphid, competition intensifies. Fungus eaters chose something else. Powdery mildew is one of the most common garden pathogens. It is everywhere where there is humidity and warmth. It practically never disappears, and among insects that eat it, there are almost no competitors, an empty niche. While everyone was fighting for aphids, the fungus eaters quietly occupied another and won. What personally struck me in the story is this. Nature independently invented the same solution several times, eating powdery mildew. This means that the solution is good, that it works, and that it has no significant drawbacks that would outweigh the advantages. And that means the beetle that implements it is doing something fundamentally right, even if we did not notice it for a long time. And now, the story of how good intentions created one of the largest ecological problems in the world of insects in the last half-century. At the end of the 20th century, entomologists in Western Europe and North America were looking for a way to fight aphids without chemicals. The Asian ladybird, Harmonia axaritis, seemed like an ideal solution. Voracious, undemanding, breeds well in captivity, actively eats aphids. It began to be bred and released en masse, in greenhouses, gardens, fields. The first years, the reports were positive. Aphids decreased, the ladybird multiplied, everyone was happy. And then it turned out that in the new environment, the Asian ladybird had no serious enemies. Parasitic wasps that restrained it in Asia were not present here. Local predators did not know what to do with it. It has a specially caustic hemolymph containing alkaloids that repel birds more effectively than in most local species. Local competitors turned out to be weaker, and the ladybird began to do what any species does in the absence of restrictions. It began to spread. By the 2000s, it was already everywhere in Western Europe. In Britain, it was first recorded in 2004. By 2010, it had reached the entire island. Local ladybird species began to disappear from their usual habitats. In Russia, the Asian ladybird appeared later, around the 2010s, first in the south, then began to advance northward. It is now being recorded even in the Moscow region. The problem is not only competition for space. The Asian ladybird eats not only aphids. When aphids run out, it switches to eggs and larvae of other insects, including other ladybirds. Local species literally ended up on the menu of the invader. It is not difficult to recognize the Asian ladybird if you know what to look for. It is larger than most local species, 6 to 8 millimeters, but the main feature is incredible variability in coloration, from almost black individuals to bright reddish ones, from 2 spots to 22, from small spots to large ones. This polymorphism is the hallmark of the species. Do you know exactly which ladybirds live on your plot? After this conversation, you may want to take a closer look. This has now become a non-indifferent question. For the 22-spot yellow ladybird, the Asian invader is a direct threat. They do not compete for food. One eats aphids, the other fungus. But for overwintering shelters and for space in the garden, they do compete. The Asian ladybird overwinters in groups and occupies shelter first. There is no room left for local species. This is a case where solving one problem created another, and now no one knows what to do with this other problem. The 22-spot ladybird is a originally European species. Its historical range covered Western and Central Europe, the Mediterranean, and parts of Asia Minor. It has always been present in Russia, but only in the European part, roughly up to the Urals. It was perceived as a background, inconspicuous species, not a pest, not a helper, just there. Over the past 3 decades, the picture has changed. The beetle began to expand its range eastward and northward, to places where it had not been before: Western Siberia, the pre-Urals, areas where it had not previously been recorded. Entomologists note new find points every season. The reason is climate. The average temperature of the growing season in Western Siberia has risen over the past 30 years. Not much, but for an insect with an annual cycle, even half a degree matters. Winters have become milder, springs earlier. The beetle, which needs a stable temperature above 10 degrees for activity, has received more such days, and at the same time, more food. Because powdery mildew also loves warmth and humidity. The warmer the summer, the more active the fungus. The more active the fungus, the better the food base for the ladybird. Another factor that no one specifically planned also worked in parallel. The gardening boom of the 1990s and 2000s sharply increased the number of private plots with cucumbers, zucchini, pumpkins, phlox, and gooseberries. All of this is ideal hosts for powdery mildew. Humans, without knowing it, created a network of feeding stations for the beetle across the country. Your dacha plot is part of this network. Now about practice. What should a gardener do who wants this beetle to work on their plot instead of dying from their own actions? First, do not apply broad-spectrum insecticides unless absolutely necessary. Insecticides do not distinguish between pests and allies. The ladybird that came to the cucumber precisely because it smelled powdery mildew there is destroyed along with the fungus. Biological control is reset. Next spring, the fungus returns, the ladybirds are gone, and the cycle repeats. If a fungicide is still needed, choose preparations based on potassium bicarbonate or biological fungicides based on Bacillus subtilis. They act on the fungus but are significantly less toxic to beetles. Second, leave overwintering shelters. A small corner of the garden with untouched leaf litter and a few old boards is already sufficient. The ideal autumn cleanup with complete burning of leaf litter deprives the ladybird of its winter home. Third, do not destroy the larvae. The grayish-yellow warty larvae on the leaves are future beetles. They eat the same fungus. Their presence means the population is reproducing right on your plot. Fourth, know the Asian ladybird by sight. If Harmonia axaritis dominates on the plot, it is harder for local species. This is not a reason for panic, but a reason to understand what is happening. 6,000 species, 100 million years, predators and fungus eaters, red and yellow, local and invaders. We thought we knew the ladybird. It turned out we knew one species out of 6,000, one color out of dozens, one strategy out of several. The small yellow beetle with 22 spots has been working in our gardens all this time, without instructions, without our permission, without our knowledge, scraping the white coating from the leaf, square millimeter by square millimeter. Millions of years before gardens, fungicides, and agronomic reference books appeared. Nature does not send obvious heroes. Sometimes protection looks like a creature you want to brush off your sleeve. The next time white coating appears on a cucumber leaf, look more carefully. There may already be someone working there, small, yellow, with 22 spots. If this conversation was interesting, like it. It helps the algorithm find people who like this too. New videos about animals and nature come out here every week. Subscribe so you don't miss them. If you want to support the channel, the U-Money number is in the description. And watch the video about flies. There is a story about a creature we hate, but without which a third of the world's chocolate production would collapse.